Hey, hi everyone, welcome back to this video series on Windows Server 2016 applications, containers, and Docker. Many of the new technologies included in Windows Server 2016 are designed to reflect capabilities provided by cloud computing, bringing your private clouds to life and granting the ability to produce within your own physical infrastructure the same solutions given to you by public cloud providers. The last few iterations of the server operating system have also resolved much around virtualization, and the idea of application containers is something that taps into both of these mindsets. Application containers are going to make the deployment of applications more streamlined, more secure, and more efficient. Containers is a relatively new idea in the Microsoft world, and I haven't heard many IT admins talking about it yet, but that will soon change. There's something that has been enhancing Linux computing for a while now, and this newest Windows Server operating system brings it a little bit closer to home for us Microsoft-centric shops. Application developers will be very interested in application containers provided by Windows Server 2016, and in truth, they probably understand the concepts behind containers much more than a traditional server administrator. While the premise of this book is not focused on development opportunities and is clearly not focused on Linux, we are going to discuss containers because the benefits provided are not only for developers. We as system operations will also benefit from using containers, and if nothing else, it is going to be important for us to know and understand how to conceptualize and how to spin up containers so that we can provide the infrastructure that our developers are going to require. Today, we're going to cover some initial topics dealing with application containers, specifically the new capabilities that are available in Windows Server 2016 to bring this technology into our data centers. Understanding application containers, the difference between hypervisors and containers, Windows Server containers versus Hyper-V containers, starting a container with PowerShell, what is Docker, understanding application containers. What does it mean to contain an application? We have a pretty good concept these days of containing servers by means of virtualization, taking physical hardware and turning it into our virtualization host like Hyper-V, and then running many virtual machines on top of it is a form of containment for those VMs. We are essentially tricking them into believing that they are their own entity, completely unaware that they are sharing resources and hardware with other VMs running on that host. At the same time that we are sharing hardware resources, we are also able to provide strong layers of isolation between VMs because we need to make sure that access and permissions cannot bleed over across VMs, particularly in a cloud provider scenario, as that would spell disaster. Application containers are the same idea at a different level. Rather than creating VMs, we create containers which are much smaller. We then run applications inside those containers, and the applications are tricked into thinking that they are running on top of a dedicated instance of the operating system. Why is this important? Let's discuss a few answers to that question. Sharing resources, just like when we are talking about being split among VMs, application containers mean that we are taking physical chunks of hardware and dividing them up among containers. This allows us to run many containers from the same server, whether that be a physical or virtual server. However, in that alone, there is no benefit over VMs because they simply share hardware. as well, where we really start to see the benefits of using containers rather than separate VMs for all of our applications, is that our containers can share the same base operating system image. Not only are they spun up from the same base set, which makes it extremely fast to bring new containers online, it also means that they are sharing the same kernel resources. Every instance of an operating system has its own set of user processes, and it is tricky business to run multiple applications together on servers because those applications traditionally have the same set of processes and have the potential to be negatively affected by those processes. In other words, it's the reason that we tend to spin up so many servers these days, keeping each application on its own server so that they can't hurt each other. Sometimes apps just don't like to mix. The kernel in Windows Server 2016 has been enhanced so that it can handle multiple copies of the user mode process. This means you not only have the ability to run instances of the same application over many different servers, but it also means that you can run many different applications, even if they don't typically like to coexist on the same server. Isolation. One of the huge benefits of application containers is that developers can build their applications within a container on their own workstation. When built with this container sandbox, they will know that the application contains all of the parts, pieces, and dependencies that it needs in order to run properly, and that it runs in a way that doesn't require extra components from the underlying operating system. This means the developer can work on the application, make sure it works in their local environment, and then easily slide that application container over to the hosting servers where it'll be spun up and ready for production use. That production server might even be a cloud provided resource, but the application doesn't care. The isolation of the container from the operating system helps to keep the application standardized in a way that it is easily mobile and movable, and saves the developer time and headaches, since they don't have to accommodate for differences in underlying operating systems during the development process. The other aspect of isolation is the security aspect. This is the same story as multiple virtual machines running on the same host, particularly in a cloud environment. You want security boundaries to exist between those machines. In fact, most of the time, you don't want them to be aware of each other in any way. You even want isolation and segregation between the virtual machines and the host operating system, because you sure don't want your public cloud service provider snooping around inside your VMs. The same idea applies with application containers. The process running inside a container are not visible to the host operating system, even though you are consuming resources from that operating system. Containers maintain two different forms of isolation. There is namespace isolation, which means the containers are confined to their own file system and registry. Then there is also resource isolation, meaning that we can define what specific hardware resources are available to the different containers, and they are not able to steal from each other. Shortly, we will discuss the different categories of two Windows Server containers and Hyper-V containers. These two types of containers handle isolation in different ways, so stay tuned for more info on that topic. We know that containers share resources and are spun up from the same base image while still keeping their processes separated so that the underlying operating system can't negatively affect the application, and also so that the application can't tank the operating system. But how is the isolation handled from a networking aspect? Well, application containers utilize technology from the Hyper-V virtual switch in order to keep everything straight on the networking side. In fact, as you start to use containers, you will quickly see that each container has a unique IP address assigned to it in order to maintain isolation at this level. Scalability. The combination of spinning up from the same base image and the isolation of the container makes a very compelling scalability and growth story. Think about a web application that you host whose use might fluctuate greatly from day to day, providing enough resources to sustain the application during the busy times weighed against too much expense for running the application during the lesser times is a difficult scale to balance. Cloud technologies are providing dynamic scaling for these kinds of applications today, but they are doing so many times by spinning up or down virtual machines. There are three common struggles today with dynamically scaling applications like this. First, it is the time that it takes to produce additional virtual machines. Even if that process is automated, your application may be overwhelmed for a period of time while additional resources are brought online. Our second challenge is the struggle that the developer needs to go through in order to make that application so agnostic that it doesn't care if there are inconsistencies between the different machines upon their application might be running. Third is cost. Not only hardware cost, as new VMs coming online will each be consuming an entire set of kernel resources, but monetary costs as well. Spinning virtual machines up and down in your cloud environment can get expensive in a hurry. These are all the hurdles that do not exist when you utilize containers as your method for deploying applications. Since application containers are using the same underlying kernel and the same base image, their time to live is extremely fast. New containers can be spun up or down very quickly and in batches without having to wait for the boot and kernel mode process to start. Also, since we have provided the developer this isolation container structure within which to build the application, we know that our application is going to be able to run successfully anywhere that we spin up one of these containers. No worries about whether or not the new VM is coming online is going to be standardized correctly, because containers for a particular application are always the same and contain all of the important dependencies that the application needs right beside that container. The difference between hypervisors and containers. While the information given in the preceding paragraphs about containers shapes a viewpoint on what a container can do for you and how it can benefit your developers, I think that talking about differences between a hypervisor and a container helps to shape a picture of what a container really looks like, and more importantly, how you will start using it in the real world. A hypervisor such as Hyper-V or VMware provides you with the ability to spin up many different virtual machines, as many VMs as your hardware can handle. Unfortunately, the number of VMs that you spin up can be seriously limited because each virtual machine is running an entire operating system. Everything from the boot kernel to the file system and processes are contained inside each and every virtual machine. This also means that each VM is vulnerable to operating system level attacks and consumes even more resources when you start adding protectors onto it, like antivirus. It is very easy to spin up VMs when you need new servers, but if you start assigning each of your VMs 8 gigs of RAM, you'll overwhelm the largest hypervisor servers in a hurry. This is where containers swoop in and save the day. Since containers share the operating system boot kernel, there is no need to replicate it over and over again as you do with VMs. You could spin up container after container after container, and you'll never have to install a new instance of the operating system. Yes, containers still have their own networking, file system, and processes, as they must, in order to do their isolation job and keep both the applications and the operating system safe from bleeding over. However, I have learned that being able to share Those core resources enables you to spin up to 4 and 6 times the amount of containers on a particular server when compared to the number of virtual machines that you would be able to run on that same server. A lot of people think that containers are intended to replace virtual machines, but that is simply not true. VMs and containers are completely different. So if you are a VM administrator, don't worry about containers taking over your day job. There will certainly still be a need for full VMs to be running in our data centers. I'm almost sure they will still comprise the majority of our infrastructure. However, containers do a great job of solving impedance mismatch between developers and IT. Let's say a developer creates an application and has it working flawlessly on their own laptop. They hand this perfect application with 0 issues over to the IT guy to put it on a server, and suddenly it doesn't work. This is a huge problem and an enormous headache for developer. Containers solve this problem because the dev work environment is exactly the same as the environment upon which the application is going to live long term. Both development and operations happen within a container. If there is a downside to be had about containers when compared to VMs, it is flexibility. With a hypervisor server, we can just as easily spin up a Linux server as we can a Windows server, and we can even spin them both up at the same time on the same platform without any problems between them. Containers, on the other hand, since they are sharing the operating system kernel, can only function that they are all running on the same operating system. This can be a limiting factor depending on what your application looks like and what you're hoping to accomplish with containers. Application developers will love the isolation and standardized compute environment provided by containers, and server administrators will love the stability of low resource utilization and containers can provide. Another huge advantage to using containers is the unity that they bring between the development and the operations teams. We hear the term DevOps all the time these days, which is a combination of development and operation process in order to make the entire application rollout process more efficient. The utilization of containers is going to have a huge impact on the DevOps mentality, since developers can now do their job development applications without needing to accommodate for the operation side of things. When the application is built, operations can take the container with the application resides and simply spin it up inside their container infrastructure without any worries that the application is going to break the server or have compatibility problems. I definitely foresee containers having an important role in our cloud-focused computing, but this will only happen if admins jump in and try it for themselves. This is one of those things, especially because the documentation often references things like application development and Linux that traditional server admins have a hard time adjusting to, and therefore have a hard time trusting. Hopefully by the end of this chapter, you will have some comfort with the idea of containers and some useful input on what they can do to help you to help your day job rather than make it more complicated. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.